Hello, welcome to the third video in this series where we're creating a solar system in 3D using the Ursina game engine and obviously coding in Python. The Ursina game engine, I'm just going to say this right at the beginning, was created by this fellow, who's a bear, obviously in real life, called Peter Amland. And this is his Patreon. Go and get involved and help him out if you can. He's also, I discovered, an amazing artist. I hope he doesn't mind me showing you his art. That's on ArtStation. Anyway, let's get back to our program. So I just counted this. I think it was 27 lines, although I'm not great at maths. About 27 lines of Python to create. Let's just make sure I've changed this number of planets. Yep, to 100. So it's not 10,000 because that took ages to kind of load. Maybe about 5 minutes, which is a long time just to be looking at your computer. Although hopefully your computer is faster than mine. So 27 lines of code to achieve the following. And remember, you have to press like S. So hold down the right mouse key or both fingers on the trackpad if you've got a trackpad like me. And then, yeah, I'm just moving backwards. And then, yeah, you can, there we go. You can negotiate our solar system as it stands. So 100 planets in a row, all textured, have all got these random colors. And we've also created like our sun, which is just my red hen dev icon. With transparencies, and actually all of the planets are kind of transparent as well. I've added some random opacity to them or transparency, and we've got them lined up. So we've got key inputs by using the editor controller or editor camera, and I can press Q or escape to close the program down. So all of that is achieved in 27 lines. So in this video, I want to get coding a lot quicker than I did in the previous two videos. And get like the main mechanic working. So we want to get our planets rotating. And are there 9 planets in our solar system? I forget whether, the issue is whether, is it planet X or Pluto isn't really a planet because it can't remove all of the debris in its path or something, which makes a planet a planet. I can't remember. I can't even remember how many planets are in our solar system. This is not the best project for me to be making. Next video, I'll look up all the data that we need. Right, so we're going to have 9 planets. I guess what we could do is at some point we want to add a name to our planet. So in the planet class here, I also want there to be the following variable name, and we'll just give it a default name at the moment called default. So that won't do anything at the moment. Also, I'm not too happy about giving them random colors. That was just me showing off what could be done. Also, if I want to show this whole line in Python, can I just do that? I think I can just do that and it will work as normal. And so its color, let's just give it the default color. What was the other way of doing colors? I think I can just write something like lime. Color equals color.lime. The texture we'll keep to the moon for now. Let's just save that. And also I want to position my planets in a better way, because at the moment I'm in the middle of the sun when we create this, and I think the planets are behind me, so I have to kind of like move, and I've done everything incorrectly. So if we make that -80 +80, so that should put the planets in front of us. And then, yeah, we want the sun. Let's start commenting a few of these things. So the sun, and that's going to be the center of the solar system. Oh yeah, in the previous video I said we should rename or name our solar system. So again, I'm ignorant. I don't know that our solar system has a name. What should we call it? I'll think about this. I don't want to let you know. This is a big decision because I'm naming it, or we're naming it for the whole of humanity. So we've got to think about it. Anyway, so that's the sun, and so once we've got our sun, we can reposition it. So I could do this. I could just say sorry, not with capitals. I could say sun.x equals, and so on. But I think if you wanted to, let me just put these on different lines as well. I think I can do this. I can say position equals, now will it be a vec3? I think that's what Ursina uses. So it uses its own vector3 object, or it might be from the Numpy module. Anyway, let's just try this, see if it runs, and yeah, take it from there. So at the moment, our sun is at 0, 0, 0. So a vector has 3 floating point components. So again, it needs to be a positive number. So let's just, and how big is the sun? The sun is scale 64, so it's got to be at least, I think the diameter will be 64, so the radius will be 32, won't it? So let's try 32. Not on the x-axis, sorry. X is 0. Y. Oh, we'll put it kind of below us as well. So hopefully that'll be a minus number. Is that right? So minus, let's go 32. And then Z, we'll go 32 positive axis. Right. Save that. Let's see if it runs. So we should have just 9 planets. They should all be default. Oh no, the lime colour. And they should be in front of us with the sun. Well, it's actually running. And it looks like the sun is in front of us and down slightly. So now we can have a look around. And where are our 9 planets? Are they still behind? No, they're going to be in front of me, aren't they? Somewhere. Where are they? Oh. I was just thinking, when we make the planets, I move them like minus 50. Or will they be above us somewhere? Don't panic, but I've lost the solar system. Where? Oh, there they are. Okay, so yeah, they were down there, to the left. Right. Let's just sort that out. So when we're making our planets, so create. No, let's be even more histrionic. Birth our planets in a loop. There we go, and then we're going to add or append them to the planets list. And I'll put that like that, planets list. So we've got 9 of them, and I'm saying, yeah, your position is P minus 50. So if I just say, let's just say P times 20. So the first one will be at 0. So that should be directly in front of the sun. And then the rest of them kind of up. Oh, and we're only moving them by 20. So let's increase that. So by 80. So they're spaced out by 80 units. I'm just thinking, how long do I want this video to be? The rest of them have been about 27 minutes. And that looks great. Oh, it's almost like an actual solar system, like from a textbook or something, where all the planets are like different sizes. And curiously, you get like those really large planets, don't you, in the kind of like the middle of the run of planets, like Saturn and Jupiter. There we go. Right. So, what was I just saying? Oh yeah, how long the video to be? Yeah. So I don't. Yes. So half an hour. That's maybe what people are liking. They like what I liked. I like 2 kind of tutorial videos on YouTube for things like Unity or JavaScript or Python. One of them I like it when it's just kind of jokey and it's conversational and it's maybe creative. Like I don't really know what I'm going to do exactly, so I'm making it up as I go along. And I like that because I tend to learn loads because loads of little things are explained and things are tried out and then they don't work and then there are bugs and all of these things are relevant. But sometimes I just want to get the answer in 3 minutes and I don't want someone talking like I'm doing now. I'm like, skip that video, go to another one that's like 3 minutes long. So if I see a video that's like 27 minutes, I'm like, I'm not going to get my answer quick enough. So what I'm doing is, in my videos, at least I'm giving you the code. So if you don't want to watch the video, people can still get the answer by just going to the code. But what I'm thinking is I could do these other videos where I call them like a speed coding thing or something like that, or speed code tutorial. And then what I do is after I've made this kind of series, I then in one video that's like 3 minutes long, make everything that I'm doing here in like 5 videos in just one video in 3 minutes, because then I've worked it all out, I know what I'm doing, and do it quickly. I don't know. If you've got any ideas or thoughts, put your thoughts in the comments. Right. So we're spacing out by 80. So next thing we want to do, I want to take away the transparency. Oh, our vector 3 worked. Who would have known? That's pretty impressive. Right. So there's a planet class. So I need to just comment a few of these. Our planet class for making planets. And then, yeah, what am I doing here? Random size. So we will take that away eventually. No, we'll have a random size because then we've got that random function in there that might be useful later on. But what we want to do is be able to specify exactly how big each planet is according to whether it's Earth or Mars, Jupiter, etc. And we can do things, has it got rings or not, things like that. What I wanted to do was, yeah, take away the transparency. Oh, I have done, because we're just setting the colour to lime at the moment as like a default. I wonder if I can do, let's actually set them to grey with the American spelling. Also, while I'm thinking about it, I want to change the colour of our background because it's kind of like grey. Let's make it black. So to do that, I think once you've instantiated your app, your Ursina app, I think now we can refer to the window and say color, and then maybe set this to, I think I can just say color black, which should be the same as saying color dot RGB 000. So I'll just leave that comment there. Right, let's just see if we've got that. Oh, and then we could, yeah, I was thinking to create this, that actually looks like our moon, so I just interrupted myself. Did I get excited? Oh, it's grey and it's using a moon texture. It looks like the moon. Anyway, that's exciting. That looks just, I can't believe this is in Python. Thank you again, Peter Amland, for this beautiful piece of software. So, we've got our dark background now. And what I was thinking, yes, before I interrupted myself, we can just have a giant sphere. You can then texture it, let's say with loads of stars, and then you basically just turn the texture inside out, so it's both-sided. I spotted in the documentation that it's as easy as just saying that the object or entity has a double-sided texture. And I think that's how the skybox works. So let's just put the skybox on, and then what I want to do in this video is get the planets rotating. And so after my little speech early on about how long I want this video, it's now coming up for 14 minutes. So let's see if I can keep this 20 minutes would be amazing, but no, it's going to be over that. Right, so editor camera, if down here I just write sky, I think this then gives us a skybox using a texture that's included with the Ursina module. So that's really impressive. You've already got this. So basically I think it's just a giant low resolution sphere. Okay, so if we maybe just got hold of, we could even use this skybox or sky sphere. We could use that one, and I think presumably do something like sky texture equals, and then we could have our own texture space. Yeah. Let's just that won't work like that, will it? If I just put texture, let's just try and use Texy, or yeah, Texy. Oh, it's in assets, isn't it? assets, in the assets folder that I made in the previous video. Assets, Texie, and then we need the skybox is obviously going to be double-sided already, sorry. Will that work? I don't know if sky is actually the name of the entity that we just created. Oh, you know what we could do? Let's just check. Name sky is not defined, yeah. Sorry, right, so how do I close this now? Let's force quit. So what we want to do is, name the sky, let's call it Jesse. Jesse is our sky, I don't know why. Jesse is the sky, and now could we say, Jesse, your texture equals Texie? Will that now work? Oh, it is. I was like, where is it? But yes, our skybox is now red hen dev icon. So sorry, I was getting confused because the sun is also using that texture. So that's there, but the skybox, it basically looks like it stays, its origin, its center is 0, 0, 0, and as you're kind of like moving the camera around, it's following you like that. Okay. So you can see the size of it means that we've got to have a very high resolution space texture on there. Okay, so let's just remind ourselves, space text. So that doesn't exist yet. So let's just comment those out. So we've sorted out the stars for later on. And maybe later on we'll create these stars more realistically, who knows. So how's my time doing? I've got 3 minutes to try and get these stars position, these planets position. So at the moment, they kind of all want to be, let's say, in the center of the sun and then move them out a certain amount. So where's their position in here? So I'm only changing their position here. Their Z position wants to be 0 because I'm moving them on the x-axis, or I guess I could move them on the z-axis and then just take this out. So now they'll all be lined up, say, behind the sun, but also higher than the sun because I've moved the sun down out of my way. Yeah, so the first one, is aligned at the sun 0, and then the rest of them go out. Okay, so we just need to plus let's plus, how big is the sun again? Was it 64? The sun scale 64, so if we plus another 80, then our first, and also now should we, okay, let's move them all down so they line up with the sun. So it's entity, so its y position wants to be, did I say minus 32? Minus 32. So yeah, their y component or height will be aligned with the sun. So we're now sat above the sun, and they're all facing outward. It shouldn't be overlapping with the sun. Okay, that's good enough. Right, so now we can get them rotating using polar coordinates. So what that means is we're going to change the x component, the x position of these planets. So that will move them from left to right, as it were. And then we also want to move their z position, so they're going that way up the z axis as they go around the sun. So z for this guy is getting smaller and smaller and smaller. It's going to 0 here, and then as it goes around the back of the sun, it's going into a minus number, and then as it goes past 180 degrees, Coming around the other side now, z is growing and growing and growing and growing until it gets to its maximum point here. And for x, the x position is getting larger and larger and larger and larger and larger and larger until it gets to 90 degrees, and then it's getting smaller and smaller and smaller until it gets to 270, and then bigger and bigger and bigger again. So z and x, they relate to or are a function of cosine and sine. So those trigonometric functions, and kind of its distance away from its origin, the center of the sun, is just this original position. So we can maybe write like a little orbit function for it. So for each planet. So just as we had this function, the initialization function, we can also write our own like member functions for the planet class of objects, and I've just gone through 20 minutes. Let's just keep going. So define orbit, and when you create a function or a method, you've always got to pass in this first parameter or argument will be the object itself that you've instantiated. So I've instantiated 9 planets, and so whenever you call one of these functions, that function needs to know which specific planet you're talking about, and it stores it in this temporary variable, which you can call anything. By default in Python, and if I was being a good Python programmer, I'd call it self, but I just want to call it this. I have issues and I want to call it this. Okay, so orbit, so what it's going to do, yeah, it's just going to, so we're going to call this function in the update loop. So at the moment in our game loop, it's just the sun that we're kind of like rotating on its own axis. On the y and the x axis. So in here we want to go, in the update loop, we want to go for p, which will stand for planet, in the planet's list. Oh, do I have to create this before I'm using that? Let's do that up here then. So I'm expecting this planets to go a different color. No, maybe I don't. Okay. So for P in planets, or do I have to call it like that? No. Okay. Right, for P in planets, so that means for every planet or object that's on the planets list, then P dot orbit. So you're just asking it to go and do some orbiting. So each time we orbit, we want to increase its orbital rotation. So we're going to have to track, well, how far is it orbited? So each planet on initialization, it's going to have, oh, did that wrong, sorry, it should be this dot name, this dot orbital theta will be nice and mathematical. That just means orbital rotation. Orbital theta equals, let's have something random. So all the planets are in different positions. So random rand int, that can be from 0 to 360. Okay, so it'll be somewhere around. So now in the orbit function, we need to say this planet's entity's x position equals something, and then this entity's z position equals something else. And we use those trigonometric functions to do that. So it's going to be the sun's position. So that's just 0, 0, 0. So actually, we don't have to put that in. So it's just going to be the radius or the distance from the sun. So we need to store that when we first create it. So once we've initialized, we also need this dot solar distance, we'll call that, or distance from Jesse. So we'll call it solar solar dist. No, I'll call it solar radius. No, solar dist, whatever. I love how I'm wasting time on things that don't matter. Solar distance equals, we'll just call it 100 as a default. And then actually we're just deciding the solar distance here. So we'll say, how do I do this in Python? Do I, to say two variables equal this? So my planet, which I'm just creating, its solar distance also equals how far away it is from the sun. Does that make sense? So I'm deciding where its Z position is, which is also this solar distance, but actually, you know what? I'm going to change its Z position by, or I'm going to work it out by in its orbital function. So the X position is something like, so it's this solar distance multiplied by, and here's the trigonometry. How do I get cosine and sine? Do I just write, is it a math function? Is it numpy? Let's try numpy dot cosine, and then we need, well, what is your theta? What's your angle? And we call that orbital theta. This dot orbital theta. That sounds very complicated, but it's not too complicated. It's just how far away are you from the sun times what angle you're at, and just pass that through a cosine function. There we go, and we need exactly the same thing except for not cosine but sine for the Z position, and that's it. Right, let's give that a go. And so what's probably wrong is this. I don't know if I have to explicitly import Numpy. I know Ursina imports it. So Numpy is not defined, okay. I don't know whether to go to like some documentation straight away or just trying to work it out ourselves. Let's try that. Import Numpy, and we'll call it as NN or MP. And then instead of Numpy here, NP, NP. And now the problem is, do I need cos like that, or cos like that, or cosine? I think it's going to be lowercase. 28 minutes. Damn. What's going wrong? Numpy has no attribute cosine. I don't know if that's the only problem. Let's have a look. Oh, I could. Now with my new software, I could pause the recording and then go and look it up. Yeah, I'll let me just put it lowercase. Try that, and then if it doesn't work, I'll pause, go and find out the answer, and come straight back, and then oh, well, that worked, but has this worked? Right, so I've got planets at different positions, hopefully all on the same axis, same height on the y-axis. It looks like that, but they're not rotating it. That's because I don't think I've actually changed the orbit, the, what do I call it, the theta, the angle. that they're at. Yeah, so in orbit, before you orbit, or after you've displayed at your current position, then this orbital theta plus equals some orbital speed. So we'll say this orbital vel for orbital velocity. I want this all to sound really spacey and intelligent. Or technical. Don't mean intelligent, technical. Right, so yeah, this orbital velocity equals, we'll just put them at 1 at the moment and see how fast that is. So they're all at the same speed at the moment. And again, what I want to find in the data on the solar system is what are the different orbital velocities, if it's called that, of Mars compared to Earth, and things like that. And that relates to, I guess, how long a solar year will be for each planet, you know, also considering how far away it is from the sun, so it's solar distance or whatever it's called in real life. Right, so, okay, so this should now be working. We should have our planets rotating. Oh, we need each individual planet for thinking for the next videos. Wow, that's much too fast, or my maths was wrong. Take your bets now, or both of those things. Oh yeah, I was just thinking each individual planet needs to have its own polar rotation, just like the sun is kind of like rotating. So its orbital velocity. Oh, it might be because this value should really be in a radians, not in degrees. But maybe we can counteract that by just saying orbital theta, increase that by orbital velocity. So let's just put this 100 times slower. To see if that works. And we're going to, I can't go any more than this, like 32 minutes. Okay, that's definitely working. Look at that. So if I kind of, I should have thought more carefully about where I'm positioning the camera at the beginning so that we don't have to keep moving around. So there we go. We've got the planets orbiting the sun, and they're all going in the same direction, and they're all going the same kind of speed, which doesn't look very good or realistic at the moment. Oh, that's kind of cool. It'd be nice to have be like kind of like further away. What I was thinking for, you know, other videos, and why I included early on the first person perspective, is maybe having a little spaceship where we can go around a little more quickly than we are here, and maybe even visit different planets and things. Basically make No Man's Sky from our little demo here. Okay, so that's looking pretty good. So, right, I'll stop the video here before it gets to 35 minutes. But it'd be interesting if actually people are attracted to watching a video this long, I don't know. Right, thank you very much for watching. Leave any comments if you've got any questions or suggestions, and I'll maybe see you next time. Goodbye.